Today we are going to talk about K3s and MicroK8s lightweight Kubernetes for edge and IoT application. So before we start our topic, let me quickly introduce myself. My name is Bhavya Sachdeva. I'm a third-year student. I'm a Kubernetes and Cloud Native Associate. I'm a Cube Simplify Ambassador, Solo Ambassador, and involving with different communities like VMakeDevs, and I'm a developer there. Apart from this, I love contributing to open source projects, and I'm a contributor at Captain and Build Packs, and I highly believe in the power of community and love contributing to open source projects, and these are my socials, so you can definitely connect with me on LinkedIn and Twitter. So this is all about me. So Aayush, would you like to introduce yourself?
Yes, for sure. We don't have much of a difference in our introduction since we have been following each other from last couple of years. But let me just quickly tell about myself. So I am a third-year undergraduate computer science student from pursuing computer science engineering from AKTU University. I am a Kubernetes and Cloud Native Associate, also ambassador at Cube Simplify and Solo, developer at VMakeDevs, and contributor to open source projects such as Kubernetes, Shifu, Captain, Solo, and various others. I have worked as a program manager in a company named Sema Software in my past, and also as a junior developer evangelist in Marico. So these are my socials, Twitter and LinkedIn. If you would like to connect with me, you can just ping me here. So let's start with the talk. Let's start with discussing some challenges around how we face problems connecting Kubernetes to connecting and controlling Kubernetes with edge devices. So the first point is managing the edge hardware. When you are working with the edge ecosystem, setting up the environment or setting up the series of devices, they play a very big challenge for you. You should be able to configure OS or the same OS in all the series of devices. Configuring the storage drivers, because since you are talking about edge, you would be having resource constraints, and that we'll be discussing in another challenge, which is limited resource. But before that, let's discuss the next challenge, which is security. And since most of us here are developers, and we are so concerned about security, our applications which we are building, it should be secure from each and every point, right? So security would include something like device vulnerabilities, network inconsistency, and all these other things. So security is another challenge if you are talking about edge. Limited resources, if you are talking about IoT and playing around edge devices, you will be having resource constraints, because you will have a limited storage to work with, a limited space to run your application on. This limited resources is the main challenge if you are playing around in edge ecosystem. The next point is using open standards, and since we are also talking about CNCF tooling, we have to keep in mind to follow all the open standards which are provided by CNCF and other edge companies as well. The next point or the next challenge is lifecycle management. Whenever you are working with edge series connected devices or working on any application which has a process, it should be, or we desire that it should be, in very continuous manner. So upgrading the process or installing new updates might hinder, because let's say you have a series of devices connected, and due to malfunctioning of any of the device, the process might hinder. So this is a big challenge in when you are working with edge and IoT device. The next point is data accumulation. So data accumulation is sending, retrieving data, also everything playing around data. It falls under data accumulation, and again it is very tedious tasks if you are working with edge devices, because you have sometimes you might work with a single edge device where you might have edge in edge devices, but most of the times if you are working with big industry or big level of applications, you have series of them connected, and in that sending and retrieving data, it would be a challenging task. The next point is interoperability. Now, interoperability is directly, telling us that you should have a connected edge devices, and connecting all these devices into a complex system is again a challenging task. The next point is user experience. Let's say if you are working in a team or if you are working on any use case, you should have an application running all the time, so that you don't break the process. And let's say if you have any teammate working on application, or you are asking help from someone, it should also be available to them. So maintaining a good user experience is also a challenging task. And at the same time, we have to keep in mind, to scale the infrastructure or ecosystem. And again, this is a challenging task. And keeping all these challenges in mind, we have to be at the minimal cost, since we are already aware that if you are working on IoT or edge device, it would consume your let's say cost, because some of the devices are very costly, and and we have to be at the minimum cost and have to deal with all these challenges. So we are in a big trouble here. But let's see how Kubernetes is helping or giving us a helping hand here. Now we all know that Kubernetes is very powerful. It has developers from all around the globe contributing to the project. Giving enhancements in various fields where Kubernetes is being used by various industries to help them in particular use cases. So we are obviously aware that it is a very powerful tool. Now Kubernetes is a container orchestration system that can be used to manage and deploy containerized applications. So Kubernetes basically helps you to abstract away the complexity of container orchestration, and by using Kubernetes at edge, organizations can easily scale and manage their applications. So we saw in the previous slide that we had a challenge of scaling and managing. Now this has been or had been taken care of by Kubernetes. It's helping us to scale and manage to an extent. Now Kubernetes provides programmatic orchestration of workloads, also efficient distribution of containers and clusters. So Kubernetes it also has easy integration with other technologies, and it helps you secure our applications. This is like sufficient points where you can be, let's say if you are stuck in any point where you are using edge as a solution, Kubernetes might help you to use it better. Now, Kubernetes has is been supporting edge ecosystem, but again, it is it alone cannot solve all the unique challenges. Let's say if you are having limited connectivity or resources, Kubernetes might not be the best solution for you. But again, it is helping you to migrate software-related challenges, and then again, helping you to scale and manage edge applications, as we saw in the earlier slides as well. So why the hell do we need a bare metal Kubernetes cluster? Let's see how some distributions of Kubernetes are helping us in achieving the best solution for edge. So we have MicroK8s and K3s as a Kubernetes distributions to discuss in this session, but there are other distributions as well where, let's say you have Microshift by Red Hat, but we are not including that in our slides since they are not like directly comparable to MicroK8s and K3s. They are, used for particular use case. They are enhanced for a particular use case, and some industries are using them there. Also, MicroK8s and K3s are like the most used distributions if you are working with edge. And also, MicroK8s initially was built for an edge solution, but it's not only like you can use it for edge, you can also use it for production level environment. So let's talk about MicroK8s a little. So what is MicroK8s? Now, MicroK8s is a Kubernetes distribution which was created by Canonical, and it is installed using Snap. Now, it is designed to run fast, self-healing, and highly available clusters. It is like the easiest way to get into Kubernetes environment. Also, it abstracts away the much of the complexity, and providing you the production level, production grade clusters, and also it supports full-fledged applications. So did I just mention micro? Yes, I did say micro. most of us, when we hear the word micro, we have a perception that it should be small in size, and this is exactly the case with micro. So MicroK8s is basically micro Kubernetes. Um, and let's see why is it micro. It is optimized for quick and easy installation of single and multi-node clusters. Single node cluster is like provided by most of the distributions, but if you are like going for very fast and easy multi-node cluster setup, MicroK8s is a good one for you. And also it provides low ops and minimal production level environment. So if you are like trying to learn Kubernetes and just want to quickly get into it, MicroK8s can be a good solution for you. Now, MicroK8s is modular in design, and you can start with nothing and just can enable add-ons. So let's say you're working on an application which has a small disk, or you have some memory constraints. MicroK8s can help you in that case, since if you are building an application, you will only be installing the tools which you want to work on, or let's say an application which has a particular use case, you will be having that if you install the bare metal MicroK8s cluster, and nothing more. Let's say there won't be any background application or any background add-ons which will be consuming your CPU or memory. So this is a best choice for edge, because we have, as we said earlier, we have resource constraints when we are working with edge. Also, MicroK8s provides you with high-level add-ons such as Istio, Knative. So such big-level add-ons with low memory consumptions is the best solution if we talk about edge. Now, you can quickly use what you need and nothing more. Exactly what I talked about right now. Just the bare metal or just the sufficient tooling is required to work with MicroK8s, and not building or working with other stuff. So let's say if you are if there is any, there won't be much chances of errors, because you know what you are doing and you know what you are building. I have like tried to explain the working, or this is like from a very basic overview. So you have an host operating system, any operating system which you are working on, and MicroK8s is installed into your operating system using snaps. So snaps is a system which it works as a channel which takes continuous upgrades. So and inside snap you have your MicroK8s controller running. And snapd is a daemon which has like all the APIs. It also like act as an interface which helps you fetch the binaries and data from Kubernetes upstream using snaptracks. So this is like the basic working of MicroK8s. Now we have talked about Kubernetes, we have talked about MicroK8s and some challenges as well. Now let's see how MicroK8s is edge compatible, and how is it helping in various edge solutions. So the first point is it is lightweight. We have discussed various points like it only installs the bare minimum things which you need to work on. Provides low computing resource footprints. So if you compare it with the other distributions, this is like the only option which is providing you single command installation, and also automatic high availability and self-healing features. Next point is zero ops with auto refresh. Now zero ops is like it is giving full-fledged cloud infrastructure level environment, and so that developers can focus on building the applications rather than handling the errors which are occurring here and there. So and also it has a feature which is auto refresh. So we did discuss about Snap in the previous diagram. Snap helps you to take auto updates from Kubernetes upstream. Now this is based on your choice. If you, let's say, want to disable this option, you can also disable it. But if you don't have it disabled, or it is default, if I'm not wrong, it takes every 6 hours. It takes updates in every 6 hours. So this is pretty awesome. So you will be like working on the latest version of Kubernetes distributions. Now it has easy clustering with automatic high availability and self-healing. Let's say if your pod is down, or your application stopped running due to some reason or due to some error, MicroK8s can help you in this case because it has like self-healing feature which where in MicroK8s will restart the container or the affected containers automatically. And this is where basically, you are having high availability. Your application will be available all the time. It is embedded Kubernetes for securing IoT edge, and also, it has enhanced security such as air gap, strict confinement, immutability to apps and operating systems, and also there is an add-on Trivy which provides you vulnerability assessments. Now, it also works with multiple operating systems, including Mac OS, Linux, and Windows. And as long as you have Snap, you can work with MicroK8s. Now, deployment is very important for Edge, and since we are talking about MicroK8s here, it also provides various API options which can be used, which has like low resource consumptions and can be used for Edge applications. Now let's talk about some add-ons. MicroK8s has two types of add-ons: core add-ons and community-driven add-ons. Now, core add-ons are like officially maintained and supported by MicroK8s team, which is working at Canonical, and that's like the awesome team. I'm also involved with the MicroK8s community, and the community add-ons is third-party add-ons, and they are officially maintained by the community folks. Which, let's say, if I take an example of any third-party add-on, Shifu, so they have like their tool, an open source project which they work on, and they also help in MicroK8s clustering. So there are like more than 40 plus add-ons working out of the box, enhance user experience, and they are highly efficient and error prone. If I talk about some common add-ons, they are Code DNS, Cert Manager, providing dashboards. And since we are talking about Edge here, if we talk about Edge add-ons, they are like, since I mentioned Shifu and also Awesome Edge. So Shifu is a really fantastic tool, which it helps you to create a microservice of any IoT device into your system, so that you can work with it or play around it. And also Awesome Edge is like the lightweight service mesh solution for Edge applications. Now, since I'm more involved with Shifu, I'm also wearing like the swag of Shifu. So Shifu provides user with a transparent framework, as I already mentioned. That it also gives you full scene device hosting and integrated software development. And by using Shifu, developers can connect, monitor, and control any IoT device, very simply. So in that diagram, we have an application Nginx pod running, and using Shifu custom resource definition controller, you can basically clone or maybe make a digital twin of any IoT device into your Kubernetes cluster. Here we have an example of thermometer. So here, thermometer is connected, which has like Shifu has made a digital twin of thermometer in the Kubernetes cluster, and then you can work around it. Now this, I have like tried to enhance that diagram. So whenever you hit MicroK8s enable add-on, any particular add-on, it directly gets installed into your MicroK8s cluster. That was all about MicroK8s, and now we have K3s, which will be like explained by Bhavya.
So thank you, Aayush, and you explained very well about MicroK8s. So now let's talk about another distribution, that is K3s. So K3s is a lightweight tool designed to run production-level Kubernetes workloads for your edge and IoT application. It is very well designed to run on any bare metal devices. It is created by Rancher, and it is also a CNCF project. Apart from this, it is a fully certified Kubernetes distribution, as it designed with half the memory. Like, I guess it is very clear with the name of K3s. Like if you see K8s, it contains 8, and it is a relation of 3 and 8. So it has a difference of around 5 units. So it is just the half the memory, as well as it designed with binary of less than 100 MB. So this is like very lightweight. It is well optimized to run on ARM 64 and ARM v7 based devices, as well as Raspberry Pi 2, 3, and 4, which makes it highly suitable for any edge, any IoT application, or even for a small sensor. So this is the K3s, like how it supports various, various architecture. And apart from this, you can run K3s on your local device using different virtualization technologies like VMware, VirtualBox. It gives you a simple, secure, and well-optimized Kubernetes workload for developing into your local machine. So this is this is the architecture and working of K3s. So it's like K8s also having control plane master node and worker node. So similarly, K3s is having server and agent with different terminologies, but the components are almost same. So it contains, like the K3s server contains with backend, API server, tunnel proxy, scheduler, and control manager. Like K8s using etcd by default. Here K3s uses SQLite as the, for storing the data, which makes it very lightweight. And K3s agent consists of tunnel proxy, kube proxy, CNI, kubelet, and containerd, the pods are running with the help of containerd. So this is the architecture of K3s. Now let's see why K3s for edge, like how is it edge compatible, and why we should use K3s. So the first one is lightweight, as it is very lightweight because it contains of less than 100 MB binary file, and this low resource requirements make it suitable for run a cluster on anything from 512 MB of memory. It is purpose built for edge. Like whenever the creator of K3s was building K3s, they remove millions of lines from Kubernetes. Like it's not a fork of Kubernetes, but they remove millions of lines from Kubernetes which are not required for the edge application. So these all features make it very lightweight. It supports high availability, but the consideration is that, like by default, it uses SQLite. So SQLite don't support high availability, or you are not capable of doing HA clustering with the help of SQLite. But with the external embedded database like etcd, you can enable high availability using K3s as well. Easy installation. K3 is very easy to install, like just a simple curl command and you are on your K3s server, which makes it easy to install as well. Simplified operation. So apart from this, like apart from these edge use cases, it simplifies things for operation as well. Like you can enable CI/CD easily here, like with the help of GitLab pipeline. It is very suitable for that. So it simplifies things for operations as well. Efficient resource utilization, like it uses around 512 MB of memory, which makes it very resource utilization. So it is it is designed very well to use resources efficiently. Air gap. You can run K3s in an air-gapped environment, the environment that is, that is without the internet. But the consideration is that you should have your binaries or, like mirror Docker images in your private registry or in an external system so that you can easily fetch these stuff. The next is minimal dependencies. So as if we compare it with K8s, it has very less dependencies. And the next point is multi-architecture and support. It supports many like ARM64, ARM32, ARM v7, as well as Raspberry Pi stuff. So it creates and it provides a support for multi-architecture. And here developers can create a centrally managed cluster where an entire device estate can be viewed by a single UI. So these all points make it comparable for edge application. So now let's discuss various packaged add-ons that comes with the K3s. So I mentioned here only 4, but there are various, packaged add-ons for K3s. So the number one is traffic. That is default ingress controller. It enables routing and load balancing of incoming traffic to services within the cluster. The second is Flannel. It supports for networking. The third one is Helm. So it provides support for Helm as well. And the last is Core DNS and the many other more as well. So it comes with various build-on add-ons. So now let's discuss various use cases. Now we came to know about edge, like the distribution. So let's discover the use cases of, these distribution. So the number one is smart cities. So K3s is, bridging topic for discussing these use cases. Like it can be leveraged to manage the cluster very easily, as well as in the smart cities. If we take the example of smart cities, it enables deployment of IoT devices, sensors, facilitating real-time monitoring, control of systems such as waste management, smart lighting, etc. So it is a widely used case there, as well as it is used by petrochemical industries, wind farm engineers. Like just imagine if any wind farm engineer have to analyze the data of turbines for around 3 lakh or 2 lakh. So going to cloud is bit expensive. So they can use K3s cluster to analyze and extract this. And there is a very good example of Hive Cell, which is using K3s cluster and working with K3s to extract value from the data produced by the IoT devices. So these are the use case. Now the second is telecommunication and networking. These both distribution provide support there as well. And the one good example of MicroK8s is like it is used by some space industries as well. Like it is widely used in spectrometer as well. So, and the third one is energy and utilities, like petrochemical industries and wind farm engineers uses these distribution. These fourth one is industrial IoT. And the last one is situations where a PhD in K8s clusterology is infeasible. This line I took from the K3s documentation. So it's just a hobbyistic use case, you can say. Like as K3s is very easy to learn. So if you want to learn about Kubernetes, you can directly learn K3s because it explains all the concepts that Kubernetes have, but with edge perspective. So these are the various use cases. Now let's discuss K3s or MicroK8s. Which one is for you? So I'm not going to, I'm not going to say that this is best or this is best. So it's just like I'm going to discover some key features of between these distribution. So let's see. So I guess with the help of this meme, it is clear. Like one side it says that K3s is for you, and the another side it says that MicroK8s is for you. So it's like selecting your lightweight Kubernetes distribution totally depends on the use case, the resource constraints, and the familiarity with the Kubernetes internal. So mentioning those points, you can use any of these distribution. Obviously, it is very difficult for software developers to make an informed choice for a specific distribution that is appropriate for a given use case. So in the coming slide, we are going to discuss some key features. So I hope these key features will definitely let you decide that which is best or which is not. But it totally depends on you. So these are some features. Like MicroK8s uses DQLite as a default control plane data store, while K3s uses SQLite, which we have already discussed as a default one. But you can use other as well, like etcd and all. Like MicroK8s consumes 540 MB of memory, while K3s consumes 512 MB of memory. So here K3s is having a little bit edge. And the other three similarities, like if you want to run both clusters, you should require at least one CPU core, 1 GB RAM, as well as these both are high availability. These both provides high availability. But the difference is that MicroK8s provides it by default, as K3s you can enable etcd here. After that, it will provide high availability. So these are the various key features. So according to these, you can decide which one is for you or which one is for and which one is not for you. And above all, these both are packed with good communities as well as good enterprise support. So this is all about K3s and MicroK8s. And Now, these are various resources which you can definitely recommend. Like these two are GitHub link for MicroK8s and K3s. You can definitely contribute to these if you want. And these two are the websites. If you want to learn more about MicroK8s, K3s, you can refer these websites. And the last one is add-on for MicroK8s, that is Shifu. So it's very new in ecosystem. So if you are interested, in IoT and created microservices for IoT application, you can definitely take a look at this. So yeah, thank you everyone. Thank you so much for listening us. And it's our very first talk in conference as a student, and it's a very big for us. So thank you so much.
Thanks for the nice talk. You told that in K3s, millions of lines for Kubernetes has been removed to make it memory constraint. And so I just wanted to know what components of Kubernetes it has been removed, but still it's a Kubernetes cluster.
Yeah, of course.
And they are able to make it 100 MB of binary file. So what components they have removed?
Yeah, for sure. Like I explained you that by default it uses SQLite. So this is the one component that it makes compared to SQLite by making kind, like which takes as a key value pair and then convert it into SQL command. Apart from this, it makes all of the components very lightweight. So this is the requirement. This makes it able to make a 100 MB file.
Okay, it have ABS server, kubelet, everything, the major components of Kubernetes it has, but the thing is how it is that much compact can make it 100 MB of binary file. That's fine. So if the database is SQLite and not HCD, how K3s is taking care of security of your Kubernetes secrets? It's not encrypted, right? So how they are taking care of security perspective in the edge devices?
No, it is encrypted there as well. Like here what happened, like I told you that server and agent. So if you install a server, firstly it will take you to the server, and after that you can, enable it by using etcd. You can enable security and high availability, not with the help of SQLite. Yeah, this is the point. Yeah.